What we're going to be really talking about today is how to secure Cosmos DB. And even though there are some areas that are quite common to all other Azure resources on the data side, but since Cosmos is a globally distributed database, it does bring some additional hassle to the game, we could say. So we're going to today mainly focus on networking and access control, because they're also some of my favorite topics as well. And we're going to, of course, start with some basics to be able to figure out how does this all link together. But with Cosmos DB, for a long time we were told that it is a fully managed NoSQL database for modern app development. But a little time ago, we got an additional word in, which said, and relational database. Because Cosmos DB actually has multiple different database options, and yes, traditionally we only had NoSQL options, but lately we also got some additions to the game. And yeah, what it really does enable is to have a very performant database for modern applications. And luckily, I've actually got a chance to use Cosmos DB. I often hear people talk about it, but not really have real-life experience of how it works and how it performs. So I've luckily gotten the chance to work on this in an actual greenfield application development project. And it does have a lot of cool features out of the box, and we do have all the different options for the database capabilities. So we are able to use the NoSQL endpoint, which is kind of the default endpoint in Cosmos DB. Then we have also Cassandra and MongoDB that, of course, link to other database platforms, not just inside of Azure. And then we have also Gremlin and the table option as well, which is the similar API that we have in Azure Storage Accounts. And then we also have the PostgreSQL option. And the thing is, it's really easy and fast to get started. You don't have to do much at all. You have to just spin up the resource, and then you can get going on setting up your database, figuring out how do you model your database in this different kind of context, and then you are good to go. But the thing comes that oftentimes when we are actually working with real-life applications, we also then have security requirements. And since it is a global service, it does bring a little more interesting factors into the game. And the question might be, well, how do we even configure security? Do we have to do something differently than in other services, or what do we do? So that's what we're going to figure out today. And hopefully after this, you will be able to have your Cosmos DB set up in a way that it's actually ready for production, and also your security department will be happy about it as well. So I am Heini Ilmarinen. I work as the Azure lead at Polar Squad, which is a small Finnish company where we focus on DevOps. I also work as a DevOps consultant myself, so do hands-on work at customers, both on the software development and data platform side of things. I am a data platform MVP as well as an MCT, so I run trainings as part of my work as well. And I am a third of the Knee Deep in Tech podcast, and I believe we are doing a live recording today, still in the afternoon, so if you want to join, come and listen to us. One of my favorite topics is architecture, and for me, security links with architecture a lot. It is something that we cannot disregard when we're thinking about how things function together. And yeah, my background is in mathematics. If you wish to talk math, you can come find me later on. I think I've been taken up on this once. And as you might have seen, I'm a bit of a serial doodler, and you'll see some more images in this session. All right, let's get a quick intro to Cosmos DB, more from the perspectives of things that actually affect how we configure security. So after we've done the intro, we're going to look at securing the networking part, and then lastly, we're going to be looking at configuring access control. Because the access control layer of Cosmos DB is different than in some of the other services, so we have to approach it in a different way. So let's start with the intro and just get sure that we're on the same page and we know what we're talking about. I do want to start off by asking, how many of you use Cosmos DB? Okay, yay, great, everyone. How many of you use it in production? A bit less hands, but yeah, still some. Okay, great. So you probably are familiar with the core concepts. So the top-level resource that we create is the Cosmos DB account. Underneath that, we can have some databases. Then underneath that, some containers, which is such an unfortunate word because it's used in Azure storage. And then we also use, containers to run a process, etc. Anyways, it's called containers or collections, and then within that we actually have our items, the data that we store in our Cosmos DB database. So if we think about this hierarchy, what we do on the account level is this is where we choose which of the different APIs we might use. So do we use NoSQL, Cassandra, MongoDB, etc. So that is where we really choose which one we use. So if we need multiple of the APIs, we do need to then provision multiple Cosmos DB accounts. So that's good to remember. The other things that we do at the account level is that we configure what kind of capacity mode we want to use. So are we using serverless or dedicated? It's not dedicated, is not the correct word, but provisioned. And then on the other hand, we also configure the geo-redundancy that we want to use at this level as well. So this affects many things, especially on the security perspective. So of course, if we have multiple regions in use, then it will also make requirements for our networking aspects, and it will affect how we can configure that part as well. On the other hand, when we talk about the access control, we need to figure out, well, which levels can we control in that sense? And that's what we'll get to in the later part. So the main idea is that the account level is where we do a bulk of the infrastructure level configuring, including networking, geo-redundancy, etc. And then the access control really comes into play once we're within the Cosmos DB levels itself. So, as said, a very short introduction. So that we can get to the main bulk of today. So what we're going to start with is first looking at the networking side. And actually, we will jump straight into a demo because configuring private endpoints in Cosmos DB takes time. It's not like a quick operation. So we want to get that rolling, and then we'll come back to the theory after the demo itself. So let's get this. There we go. So I've provisioned a Cosmos DB account earlier today. And what we're going to want to do is create a private endpoint for it. For that, we, of course, want to also have a virtual network where we configure this. But let's actually, before we get there, let me just take a step back. Oops, wrong click. What is happening? I had some interesting phenomena happen with the portal today, so I hope that does not come back. So if we talk about the networking aspect of Cosmos DB in general, by default, all networks are allowed, which is oftentimes not quite desirable. We have the option to choose selected networks, where we can then configure a service endpoint with the virtual network selection. So we choose a particular subnet that we want to allow our traffic to originate from to our Cosmos DB account. And then in the Cosmos DB account, we tell, hey, OK, you can let this traffic in. Or you can add single IP addresses to the range. But oftentimes, we talk with Cosmos DB. It might be either some data level developers, or it is the application that is talking with it. So maintaining a list of whitelisted IP addresses can be actually quite difficult, and it can get messy in the long run. So oftentimes, it's much more desirable to have some kind of private networking configuration, and for that, we are going to need the private endpoints in place. So let's start with just setting up our virtual network real quick, where I can tell a few details about that. Uh-huh. So, with our virtual network, we're really creating a private network for us where we can then configure our resources to be configured in a secure manner so that they also talk securely to each other. We often then, with Cosmos DB, of course, there's the Cosmos DB part that we need to figure out, but then oftentimes we also need to figure out, well, how do our resources communicate through this virtual network as well? So when we create a virtual network, what we need to give it is an address space, and I really think of the virtual network level address space more like an address space allocation for that. You can add more addresses later on if you like to, but really when we're setting ourselves in when we start to configure the subnets. So for our purpose, we don't want the default subnet, but instead we want to add a backend subnet for our Cosmos DB. There we go. And then you, of course, need to say what is the address range for that. And it's always better to have a little too many than a little too few. The subnet address ranges are not so easy to change after the fact, so pay attention to really calculating how many might you need in the long run. So that's all we need for now. So we're just going to let that get created. It won't take long at all. So while that is happening, we can already get to the actual private endpoint part of configuring Cosmos DB itself. So that is actually all ready. So within Cosmos DB, we can get to the private endpoints through the networking section, and it will be able to choose some of the things for us by default correctly. And let's just give the private endpoint a name. And I've been in West Europe here, so let's go with that. And it actually has quite an important text here to make note of. So the private endpoint must be in the same region as your virtual network, but can be in a different region from the private link resource. So you can connect across regions, but the important thing is to have the private endpoint in the same region as your virtual network. So then what we need to choose with a private endpoint, always, whatever the resource might be that we're doing, is to choose the resource. I still have not figured out that when you start from a Cosmos DB, why it wouldn't be able to default to that. But anyways, would seem like quite a reasonable thing to do. So we choose our resource, and then we choose our sub-resource. And the sub-resource that comes up depends on the Cosmos DB account type that you have. So for the choice that I made was the NoSQL endpoint. So for me, it just shows the SQL sub-resource. But if you choose something else, it will then display those other options. So you could have MongoDB or Gremlin or something like that visible there as well. And then we're going to choose the virtual network that we just created. We're going to allow it to do its thing on its own. And then we get to an important part, which is the DNS. So I'm going to allow it to create that by itself, and we'll look into a bit of details in just a moment. And we'll just click through and let that get rolling, because as I said, it takes quite a bit of time. But the process itself of creating a private endpoint is quite simple. If you do it using things like infrastructure as code, you will notice that there's quite a lot of dependencies behind the scenes, actually, that are not so evident when you go through it from the portal. So you might notice that it can be a little more difficult, but there's good resources out there that have the samples in place. So be sure to use those if you're using infrastructure as code. So with that, we can return back to the slides, and maybe then I can make a little more sense of what we actually just did. All right, that went well. All right, so we created a virtual network for ourselves, and there we allocated a specific IP address range for that VNet. We're not going to go into the calculation of those today, but it is a bit of an art itself. I talked to a colleague of mine who does a lot of networking, and he pretty much says, well, he remembers them all by heart. So he does not need any calculator for it. And I think that's experience for you. I cannot quite do that. So feel free to use the calculators available, and the portal gives you nice feedback as well. Then we need some subnets to actually deploy our resources. So in our case, we deployed this backend subnet and gave that an IP address range as well. We probably have also some kind of application. And if we are doing private networking, then that application is probably in our private network as well. So make sure to think about the networking from that perspective as well. What we need to note is that every time we create a subnet, Azure allocates 5 of the addresses for its own use, and that is what enables things like broadcasting and routing to work correctly within your Azure virtual network. And those will always be lost from the address spaces that you have. So just take that into consideration when you calculate how many addresses you need. The other important aspect is that within a virtual network, there is Azure-provided DNS automatically in it, unless you specify otherwise. And that will take care of the name resolution in your virtual network, as long as you have things that natively reside in a network. So actually, that means only virtual machines. So if you do have PaaS services like Cosmos DB, you do need to do a few other things to make actually things work if you use a private endpoint. And we'll get to that in a moment. And so this Azure-provided DNS actually does have a magical IP address. If you ever come across that, that is what it's referring to. It's not visible in many places anymore, but occasionally you will come across it and be a bit like, what is this even talking about? But if we look at the flow of name resolution, and we have an application in our virtual network, and then we have Cosmos DB in our environment as well. By default, that Cosmos DB has a public endpoint, and as with any other Azure resource as well, that is a PaaS service, it also has a fully qualified domain name that ends with the document.azure.com, and in the case of Cosmos DB. And actually, well, that is not exactly correct. That is for the NoSQL option of Cosmos DB. So there is actually different naming for the different APIs. And that becomes relevant in a bit, even in a little more detail. So when our application goes out and goes, hey, I want to know where do I find this document.azure.com with your specific name in it, it goes to the Azure-provided DNS first, and that actually routes it to the public DNS services. And then we get back the IP address, the public IP address of our service, and we're able to connect to the public endpoint of that service. And since I mentioned the service endpoints, it does actually work the same way when you use service endpoints. Sometimes with service endpoints, it feels like it's a more private configuration, which it is a little bit, but it's still, you still have that public endpoint available, but you're creating a trust relationship between your subnet and that public endpoint that you have, that it can only receive traffic from that particular subnet. If we look at the private endpoint part, which is our main focus today, in that case, what happens is that we create a private endpoint which always gets deployed to a certain subnet. So you tell it where you want it to reside very specifically. You want that to be in that subnet. And once you create that, we also delete the public endpoint of our service in Azure. And then we are able to connect our private endpoint to our service. It is actually possible to have a configuration where you have the public endpoint and you also have a private endpoint. But you should be aware if you do that, that it is actually intentional and not by accident, that you just accidentally leave the public endpoint available as well. And with a private endpoint, what we get is we actually get an IP address for that service from the subnet that we specify, and then that gets linked to our single specific resource. So when we start to do the name resolution for this, what happens is when our application goes to the Azure-provided DNS, it actually gets a different kind of result. it gets back that, hey, we have this private link.documents.azure.com answer for this actual name resolution that we're trying to do. And that tells it that, hey, actually, this now has a private endpoint that we need to check. So what happens then is we do need to have some kind of private DNS in place, and the easiest way to handle that is the private DNS zones. That is what I allowed kind of the process to create itself. And that will be able to give and track the records for this private link DNS zone that we have in place. So then the answer goes to that private DNS zone, and then from that private DNS zone, we have an A record that replies with that IP address, and then we are able to go to that endpoint through that private IP address. It's good to note that we cannot actually call the service by the private IP address directly, because there is certificate checks in place in all the Azure services. So you're not able to just like figure out what the IP address is and then just use that to call it. You have to use the fully qualified domain name. All right. Yes, at this point. Let's go back here and let's see how far we have gotten. It could be that it's still a few more minutes, but let's see. So we have our virtual network, we have our private endpoint that has appeared, and then we also have a network interface card, which is actually the resource that contains the private IP address specification itself, and that information for the resource. And then on the Cosmos DB side, we can see on the networking pane, if we look at the private access side, we can see that there is this private endpoint that has been approved. And then we should also see here the custom DNS record for it. And what we will see that is very different from other resources is that even when we created one private endpoint, we actually ended up with two. So what's up with that? That has to do with the fact that Cosmos DB is global service by nature. So even though I just created this for one particular region, I ended up with two endpoints. And if we look at the names, we can see that, well, there's this documents.azure.com, but there is also this westeurope.documents.azure.com endpoint there. And that is what is really telling us that, well, actually Cosmos DB always has a global endpoint, but it also has a local endpoint. So since my account is in West Europe, it also has this West Europe endpoint that it's able to use. And I haven't got an exact answer of why does it take so long to deploy this, but it does seem that it is due to this global nature that it actually has to go into both places and configure that. The one thing to note is if you make this configuration change so that you've had, for example, the firewall rules in place previously and you want to switch to using private endpoints, is that this is an operation that does make the service unavailable for a few moments. So, or if you're just changing the private endpoint configuration in general. So you want to ensure that you have at those times, if you don't want any break in your application, make sure that you have like some kind of access rule in the firewall that allows your application to keep communicating while you're making the private endpoint changes. All right, that's now complete. So you notice, I think I was talking for 10, almost 15 minutes in between, and now it said it's complete with the deployment. So it's not, the resource is not available for all that time, but there's a little time window where the private endpoint side is not reachable if you change that configuration. All right, so we actually do have both of these endpoints here. Let's get to the private DNS zone here as well directly. There we go. So you can see it is this private link.documents.azure.com. And if you use the private DNS zones, it does have to have that specific name. And the names that you need are slightly different for each API. So make sure you check the correct format for that. and you can find that in the documentation. And then if we look at the name records here, we can see we have the two different endpoints, both the regular and then the West Europe specific endpoint there as well in our DNS zone. And this is what makes it work within our virtual network. If we need hybrid connectivity, then you need to configure DNS forwarders and things like that. It is slightly outside the scope of today, but if anyone has questions about that, we can chat about it after the fact. All right, so clear so far how the configuration goes? Great. All right. The other thing that we need to note is that, of course, in the case of Cosmos DB, it is possible that we don't have just one region. And that's where things start to get even more interesting. So it might be that in our replicate data globally, we have this enabled, and we then have another region in place. It could be anywhere. So we can just choose which regions we want. And the nice thing with Cosmos DB is that it handles the replication, and we then can just set the consistency level, how we want our data to be replicated, and all that is handled for us. But how does that affect our networking is the next question. So if we start to figure out, well, what do we need to do with networking in that case that we actually have two regions available? So we enable the second region and we replicate the data between these two regions. Then, well, that actually means that we need to have also virtual networks in both regions if we really want to have high availability in place. And that means then also that we need to have private endpoint configurations in place in both virtual networks that we can actually reach our Cosmos DBs from both places. And then if we have our application layer, like if we think about the different Azure services that we could use for application deployment, we could, for example, think that we might have an app service or something like that. That is not globally available in the same way as Cosmos DB. We don't have just a little click box that we could say, hey, I want this to be actually deployed in two regions. So what we would then need to make sure that we take into consideration is that we also replicate our application layer in both locations. With this, you can, of course, think, what are your requirements? Do you need this to be available in this replicated manner all the time? Or do you just need to have the capability to put the resources up in a second region when you need it? So that is, of course, always a factor that then affects the price, because you don't have to have the resources running all the time, and then also affects how long it takes for you to recover from a scenario. Because, of course, if you have to deploy some resources, when things go wrong, it will take a little more time. So really think about this global setup if you do have that scenario in your use case. But also remember, you can still use Cosmos DB in just one region, and that's totally fine as well. But if you do use it in many regions, make sure you take into consideration the networking part as well. You might note also from the private endpoint configuration that it's stated that you can have the private endpoint needs to be in the same location as the virtual network, but the resource itself can be in a different region. So you could also, configure the locations kind of mixed, but then note that if there's a region that goes down, it won't help if you do that. So you do really need that virtual network level and application level replication to two different regions if you want to be protected against that scenario. All right, any questions about networking part? Yeah, go ahead.
How do you keep track of all the IP addresses when you're creating all the DNS? Is there an app or a tool that you can just put in and stops you from overlapping?
Yeah. So the question is there any tool to ensure that we don't accidentally plan our networks on top of each other? The thing is, well, I haven't looked that closely for it, so it might be that I just don't know. But the networking people I've talked with, most of them use Excel and track in an Excel sheet the IP addresses that they have. Some companies, like if they have tooling on-prem already, some like the network tooling might also include the capability to then put your Azure networks in as kind of like just for you to see all the IP addresses that are in use. But I'm not a specialist in that area, so if anyone has a clear answer, feel free to hop in here. But yeah, you can use the management APIs to figure out what IP addresses are assigned and what are not. But then you again have to make sure that they don't overlap in some way. Yeah. And it is an important point. If we connect the networks, then we definitely don't want them to overlap each other. Then to the second big chunk of this session, configuring access control. It's an important part of Cosmos DB. I worked with Cosmos DB for the first time, I think about 3 years ago, it must be now. And at that time, there wasn't really, at least from my point of view, there wasn't any good options. And so if we look at Cosmos DB, we have now 3 options, luckily. And the first 2 were around already before. So we have the primary keys that are available, but that is essentially a master key to your Cosmos DB account. So no, you don't really want to use that. I don't think you ever should need to use that. Unfortunately, there are still tools that only support primary access key type of cases. So sometimes you might have that requirement, but hopefully you don't come across that. The other option that is there is resource tokens. And that is where you can create a token that has a specific lifetime and it has a specific scope of what can you do with that token. So that is already much better. But the issue with that is that it's still not linked to any identity. So anyone can use that token if they get a hold of it. And traditionally how this went was that within your application you would create a token for the span of time that you need it for, and then you would recreate it. But you have no big picture of what kind of tokens do you have they expired when they needed to, or has somebody actually made tokens that have an almost unlimited lifetime. So there wasn't really a good way to figure out what was actually going on. So about a year and a half ago, there was Cosmos DB RBAC that came into play that gave us the capability to use Azure AD identities to configure access to Cosmos DB. And I feel like it was kind of luck that I got to actually use this right away when this came out and configure it from the beginning. And it is already in GA and it has been working from the very beginning really well, actually. So it is something that I can recommend and have seen working in production as well. But you might think like, well, what is the benefit of using Cosmos DB RBAC and why should you go for it? And essentially it is relying on Azure AD. So it is really the question of why should you rely on Azure AD instead of these tokens? And the main thing is that, well, for each user and application, you are able to get them to use their own identity. So you no longer have these keys that could be used by this application and that other application, and you have no way to distinguish between those two. And if you do have that situation, it's actually also much harder to figure out if your key has, for example, been compromised, because there are different ways in which that key is being used. Whereas if it's just being used by one user or application, then you are able to much more clearly see what are the regular patterns that happen there. And if you see something suspicious, it's much more easy to identify. Secondly, you can use Azure AD capabilities. So for example, if you use it also for your users, then they could be prompted for MFA and things like that as they sign in as well. So when we talk about this particular scenario, oftentimes we have an application talking with our Cosmos DB. And what we are then able to do when we use this is we're able to leverage managed identities if our resources are in Azure. So we can create a managed identity, for example, for our app service, and using that managed identity, we can then connect to our Cosmos DB. And the same applies also for our users and groups. So we can leverage those identities, and if they need to connect to Cosmos DB directly, then they can use that as well. The color isn't very good, but anyways, I hope you can see. So in this way, we're able to really take control of who can access Cosmos DB and what they can do. But let's see how this works in practice, because it might not be quite evident. If you go to the Azure portal, there is not really anything indicating this. Yes, we can find the keys, which are... Sorry, something is weird today with portal, but anyways, we can find the keys here, and we could use them. And yeah, we do have read-only keys, and we could, of course, like with that, have a little more restriction. But again, it is a master key, so it's not really a recommended approach. So what we can do with the Cosmos DB RBAC, we do need to note that it is not Azure RBAC. So if we come in and try to create a role, well, we cannot find any Cosmos DB data level roles. We can find the administrator roles for Cosmos DB, but we cannot find anything else. And I do find the Cosmos DB account reader is a little misleading in its descriptions, because it says can read Azure Cosmos DB accounts data, but that means the management level data, like configurations, monitoring data, etc. It doesn't actually mean the data in the Cosmos DB itself. So slightly misleading, I would say. The thing is, with Cosmos DB RBAC, we are only able to create it using programmatically at this point. So we are not able to use the portal. So what you need to do is that, well, there is two built-in roles. There is a data reader and a data writer, I believe. But if you need to do anything more than that, you need to create a custom role for yourself, which is most of the time the case if you have an application actually running. You might not, for example, want it to have access to all the databases in your account or all the containers. So you can also restrict that in that level. So what we need to do is create a JSON representation of what is the role name, and the type needs to be custom role, and then we are able to define the assignable scopes. This means the account level, so that is the level where you're able to assign it. And then we have a list of permissions that has these data actions in place that are allowed to do. So for example, this particular role, that is this read-write role, has the permission to read this metadata in the database accounts level. Then it's also able to read the containers items and so forth. So you need to define which kind of actions you want there. After you have created this JSON document that defines which things you want that role to do. So let's just grab here. I'm just going to set my variables here. And then we first need to create a role definition. So that becomes something that you can use then in your account across different areas. And then you can affect by the scope where it can actually be assigned. So we're going to create a Cosmos DB role definition. So you need to specify the account, and you need to specify the resource group, and then you hand in the JSON definition of that role in this body parameter here. And then it will put that role into your Cosmos DB account. This normally at least does not take very long, a few moments, but not extensively. And after that gets created, let's just fetch the roles that we have in here. So from this one, we can see the role definition that just got created. So if we now list everything from our account, it will actually return a few more. So it will also return the built-in roles. So you can see there's a Cosmos DB built-in data contributor. So that can do pretty much everything on the data level. And then we have the Cosmos DB data reader as the second role here. And for both of these, you can also then see the data actions that they enable and can kind of figure out what is the scope of those. And if needed, you can also then do not data actions as well. So define what is not allowed. So with that, we have those roles, and then if we would want to assign this to a user, we would need to get the ID, role ID for this, and that is actually this name field from here. So it's not the full-on string ID there, so that is a little maybe misleading. So it's not a resource ID that we need, it is the ID itself, and then we would just populate the principal ID as well, so either the user ID or if we have a managed identity, then for that, and then we would be able to assign that role. And with that, we can define the scope, but of course it has to be something that is allowed in our role definition. If it's not, it will give you an error and you're not able to actually assign it to that user. The good thing also about using the Cosmos DB RBAC roles is that after you have configured them, then you are able to add in the diagnostic settings, the capability then to get those role data level operations. So nowadays there's much more requirements for also having the auditing level to the data plane actions. So then that also gives that capability to us and can be also very helpful in troubleshooting scenarios and not just from the auditing perspective. So that's how you create the roles and role assignments. Again, you won't be able to see them from the portal, so you need to figure out ways that you, for example, assess them. So you would, for example, run the list scripts and format them a little nicer so you can get an overview of what kind of definitions and assignments you have in place. Great. So just to recap, kind of what are the options for you when you are defining the scope. So you can either define the database account level, so that's what we had in the sample there, or you are able to define the scope for the role, note the role, at the database level, and then you also have the option to define it at the container level. So there you just then give the database and container names to point it to the right place. So with that, you can see that you are able to actually get very granular with the RBAC if you need to, but also remember, don't go more granular than you actually need to, so that you don't make things more complicated for you than is required. Great. So what we've been going through today is we had an intro to Cosmos DB, mainly to the structure and how that affects specifically the security requirements and configuring the networking as well as the access control. For networking, it is very much an account level thing that we are doing. So if you have multiple databases in your Cosmos DB account, that means that those networking configurations will apply for all of the databases and containers that you have in your Cosmos DB account. And then when you go to access control, it is really good to use the Cosmos DB RBAC because it gives you much more visibility to your users and applications that are using it, and you are able to then ensure that there's no random access to your application, and are able to also leverage the visibility that you gain from there. And if you do that, then you are able to, sorry about that. If you do that, then you will be able to really configure your application for the scenarios where you have complex needs for data access, and you are able to even maintain scenarios where you have multiple applications accessing data from different areas of the Cosmos DB account. So with that, I want to ask you, do you have any questions about access control or networking or other security aspects of Cosmos DB? Yeah.
So question about the moving the region setup and the DNS zones.
Yes.
Do you get separate DNS zones for both regions, or is it the same?
If you're, so there's a little, I should have drawn it out here, but if you are getting into a scenario where you notice, so let's actually go back a little bit. So when you create the DNS zone, it gets linked to a virtual network. And that tells the virtual network, hey, you can use this DNS zone. And so if you notice yourself getting into a situation where you then have two virtual networks and you have separate DNS zones for both, but then you realize you have to link them to both virtual networks. That doesn't actually work. So you cannot have two separate DNS zones that have the same name linked to two separate virtual networks. The thing is, though, that the DNS zones are global in nature, so you don't specify a region for them, so you can assign them across regions. So if you need the same name resolutions for both regions, then you should just use centralized ones. I have seen scenarios where there's a need for split functionality, but split DNS zones always gets a little complicated and gives more rise to issues, and it's harder to troubleshoot, etc. So unless really, really needed, I would rather go with a centralized approach with the DNS zones. It makes your life easier. Great. All right, any other questions? I didn't have any questions from there. Great. Yeah, with that, thank you so much for joining. If you have any feedback, please take the time and leave some for me so I can make this session better. And thank you so much for joining. I hope you've had a great SQL Bits and still have a few more sessions to enjoy today. So if you want to reach out to me, you can find me both on Twitter, LinkedIn. I almost said that. That would be great. Twitter and LinkedIn. Feel free to connect and send any questions that you might have after the fact and any scenarios that you're trying to figure out. Thank you so much.